To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students. So I'm going to continue with the extra questions related to current electricity. We have discussed some questions in the previous chapter as well. So you're familiar with the concepts. We started off by discussing static electricity and current electricity. Then under current electricity, the relationship Ohm's law, where we discuss V equals IR, where V is the voltage or the potential difference, I is the current flow, and R is the resistance. Thereafter, we discussed different types of resistors. Fixed value resistors, variable resistors, and light dependent resistors. And finally, we discussed how we can combine resistors to get an equivalent resistance. That is the resistance that is needed for us by combining resistors in different ways. Under that, we discussed the series combination of resistors and parallel combination of resistors. So in relation to that, I discussed the questions in your textbook. Then after that, the MCQ type questions. And now finally, the questions where you need to write answers. So I'm sure you will try to answer the questions first and then you will compare your answers with my discussion. So extra question 11. A nichrome wire coil has a resistance of 8 ohm. So when you look at the question, you all have to extract the information that you all know. So here the resistance is 8 ohm. And when we say nichrome wire coil, immediately you can remember. Nichrome is an alloy of nickel and chromium, and nichrome has very high resistance. That is why when electricity passes through nichrome, there is a large amount of heat released or heat produced. Most part of the electricity is converted to heat energy because of its high resistance. Then, when it is connected to a power supply, a current of 1.2 amperes flows through it. What is the potential difference across the nichrome coil? So, the data given to us are R equals 8 ohm resistance and current I equals 1.2 amperes. And what do we need to find? We need to find potential difference or voltage. So what is the relationship? Ohm's law. V equals IR. At constant temperature, when you apply a certain potential difference across a conductor, the current flowing through the conductor is directly proportional to the potential difference. And from that, when you get the equation, potential difference divided by current gives you a constant value, that is the resistance. From that only, we get the equation V equals IR. So here, of course, you have I and you have R. So directly you need to substitute. I is equal to 1.2 amperes and R is equal to 8 ohms. So when you multiply 1.2 amperes by 8 ohms, what will be the answer? 9.6 volts. 9.6 volts. So that is the potential difference across the nichrome coil. So this is a direct question, students. You need to use the equation for Ohm's law. Substitute the values 1.2 amperes and 8 ohms. So the answer will be 9.6 volts. With that, we will move on to the next question. Extra question 12. So when a bulb is connected to a 6 volt power supply, so here potential difference 6 volt, a current of 0.4 amperes. So current is 0.4 amperes. What is the resistance of the filament of the bulb of that instance? So here there is a filament bulb through which current flows and electricity is converted to light energy. So there the potential difference is 6 volts, current is given as 0.4 amperes. They want you to find the resistance R. So like I said in the previous question, the same equation. V equals IR. But what do we need to do? We need to make R as the subject because we need to find R. So you can rearrange first. R is equal to V over I. This is the relationship, no? At constant temperature, current flow through a conductor is directly proportional to the potential difference applied across it. So that gives you the constant R. You can rearrange and substitute, or you can substitute the values and rearrange. So here you will get the values 6 volts divided by 0.4 amperes. And that will give you the resistance. So this is going to be, if you simplify it, 6 divided by 0.4, you can divide 60 by 0.4. So 50. So that is going to be 15 ohms resistance. That is going to be the value. Is that clear to you all, students? So here we need to find the resistance. So we rearrange the equation and we get the answer. 6 volts divided by 0.4. So you will get the value as 15 ohms. Then, if you do it the other way, still you will get the same answer. You can also substitute V equals IR. Here you can substitute V 6 volts, I is 0.4 amperes, and then R. From this you can rearrange and get R is equal to 6 over 0.4, but you will get the same answer, 15 ohms. So either the first method or the second method. It's up to y'all. Whatever is convenient for y'all can use the method. Rearrange and substitute, or substitute and then rearrange. So that is how we find the resistance of the nichrome coil. So with that, I'm going to move on to the next slide. So here we have extra question 13. The resistance of a nichrome wire coil is 12 ohms. So again, related to the similar equation, resistance is given to you. That is 12 ohms. Then when it is connected to a power supply of 6 volts, what is the current flowing through the conductor? So now from the last 3 questions, this one and the previous 2 questions, you all can see, students. When we use the equation V equals IR, they will give you all 2 values and will ask you to calculate the third quantity. So here the values given are resistance and voltage. You need to find current. So if we write the equation here again, V equals IR, I will substitute first. 6 volts, that is equal to I we need to find, and R is given to you all as 12 ohms. So if you rearrange now, I is equal to 6 volts divided by 12 ohms. So 6 over 12 is going to be 0.5 and the unit amperes. So that is the current flow through the here also nichrome wire coil. Is that clear to you all? So here also, students, like I did in the previous question, you can use the method where you rearrange first. So from V equals IR, if you want to find I will become the subject. You will have to divide potential difference by resistance. So what we have done here, you can rewrite before substituting. You can rearrange the equation and you can find the answer. Either way, it's fine. It's up to y'all. Whatever is convenient for you, you can use the method. But always remember, you have to write the equation first. Then you need to show the substitution. And then only you find the answer. So with that, students, I'm going to move on to the next question. So extra question 14. First one, what is resistance? So you all know, students, when we have a conductor, conductors are materials that allow current to pass through them easily. But still, they do oppose the current flow. So the opposition or the ability of the conductor to oppose the current flow through it is what is known as resistance. So all the conductors, even if they are very good conductors, still they have a resistance. So you are familiar with that. That resistance depends on the material composition. That is what we call as resistivity or specific resistance of a conductor. So all materials, even though they are very good conductors, they still have a resistance. That means they oppose the flow of current through them. So that is what resistance is. So we can say the opposition by the conductor against current flow, or we can say the ability of a conductor to oppose the current flow. That is what we call as resistance. And we all know, students, when the resistance of a circuit increases, that is the equivalent resistance, the current flow through the circuit decreases. So that is why we use resistors. We use resistors to control the current flow. So if you want to reduce the current flow, you need a higher resistance. If you want to increase the current flow, we use a lower resistance. So resistors are like the taps where you control the water flow. Similar to that, by using a resistor, you increase or change the resistance of a circuit, and by doing that, you change the current flow. So basically, resistance is used to control the current flow through a circuit. So to get that resistance, we use the resistors. I'm sure you all can remember that concept. So then, the second part, write the factors that affect the resistance of a conductor. What are the factors that affect the resistance of a conductor? One thing you all know for sure, temperature affects the resistance. That is why when we discuss Ohm's law, we say at constant temperature, V over I is a constant and that is the resistance. So if temperature increases, the resistance will increase. But if you consider a conductor, there are three factors that affect the resistance of the conductor at a constant temperature. What are they? The cross-sectional area of the conductor, or you can say surface area of the cross-section of the conductor. Then the length of the resistor and also the material of the conductor. When we say material, that is referred to as specific resistance or resistivity of the conductor. So three factors. Write the factors that affect the resistance of a conductor. So here the first factor is cross-sectional area. Cross-sectional area. Then we have the length of conductor. So here also we can say cross-sectional area of conductor. Length of conductor and material of the conductor. Material of the conductor. Here. Under material, I will just mention the terms specific resistance, or resistivity. Specific resistance or resistivity. So, three factors: cross-sectional area of conductor, length of conductor, material of the conductor, that is given in terms of or discussed in terms of specific resistance or resistivity. I am sure you all can remember that. So, how do they affect the resistance? When cross-sectional area increases, resistance decreases. More current will flow through it. When length of conductor increases, resistance also increases. So, therefore, less current flows through it. Then the material of the conductor, of course, if you take copper, copper has less resistance compared to iron. Iron in turn has less resistance compared to nichrome. So, nichrome is a substance that has somewhat high resistance and copper is a metal that has less resistance. So, that is how the material comes to affect the resistance. I am sure you all have answered these correctly. So, with that, students, I'll move on to the next question. Extra question 15. First one, briefly state how the cross-sectional area of a conductor affect the resistance. So, just what we discussed. When cross-sectional area increases, the resistance decreases. That is how cross-sectional area affects the resistance. So, we can write resistance decreases when cross-sectional area increases. In other words, how can you say? Or vice versa, you can say resistance increases when cross-sectional area decreases. So, we can say resistance increases when cross-sectional area decreases. So, you can compare these to a PVC tube. If it is a small tube, it's difficult for water to, for a fixed amount of water. If you have small tube and large tube, the amount of water can flow easily through the larger tube, whereas it is difficult for it to flow through a small tube. Something similar to that. So, when the cross-sectional area of the conductor increases, the current can flow through it easily because the resistance decreases. So, that is the first one. Then the second part. Briefly state how the length of a conductor affects the resistance. How does the length affect? When the length increases, for each unit length, you have the same resistance. So, that means when length increases, the resistance increases. So, that will decrease the current flow through the conductor. So, here we can say briefly state how the length of a conductor affects the resistance. Resistance increases when length increases. So, in other words, resistance decreases when length of conductor decreases. So when length increases, the resistance increases. When length decreases, the resistance also decreases. So that is how the length of a conductor affects the resistance. Then, the third part of the question, do different metal conductors with the same cross-sectional area and length have the same resistance? Do they have the same resistance? No. Why? Because of their material composition, they have different resistivity. So, because of their resistivity, the resistance varies. We have done the activity where we saw how the length affects the resistance, then the cross-sectional area, and also the material composition. If you can remember, we use 3 wires: nichrome wire, iron wire, and copper wire. And you saw the current flowing through the copper wire. They had all of them had the same length, same cross-sectional area, and the current flowing through the copper wire was higher. Why? Because the resistance was less. But the current flowing through the nichrome wire was the lowest, and the brightness of the bulb was the lowest. Why was that? Because the resistance of nichrome is the highest, and iron has in between resistance. So if you arrange them in order, copper has the lowest resistance, then iron and nichrome has the highest resistance. So there, the resistance depends on the material. When the cross-sectional area and length are same, the resistance of different conductors is different depending on their material composition. So to answer the question, do different metal conductors with the same cross-sectional area and length have the same resistance? The answer is no. And why? When the material composition changes, the resistivity of the conductor changes. Then the resistance of the conductor depends on the material. So that is the reason. When the material composition changes, the resistivity of the conductor changes. Then the resistance of the conductor depends on the material. So you can remember that, students. We did this activity where we had 3 different conductors, same length and cross-section or cross-sectional area, but one we had copper, the other one we had iron, and then we had nichrome. And if you take nichrome, it has the highest resistance. Then we have iron and we have copper. So this is the resistance. And you can remember, students, when we did the activity, we had a light bulb and also we measured the current flow using the ammeter. So current flow through copper was higher, current flow through iron was somewhat less, and through nichrome it was the lowest value. And also the bulb. The bulb will be very bright when you use the conductor of copper. Then if it is iron, the brightness decreases, and when we use the nichrome conductor, the bulb lighting, it was very, very dim. The brightness was very, very less. Why? Because the resistance of nichrome is high, so the amount of current flow will be less. So therefore, the brightness of the bulb also was less. So that is the activity. This is for you all to recall what we have learned in the lesson before and from the activity. But the answer for the question is up to here. So when you say when the material composition changes, the resistivity of the conductor changes. Then the resistance of the conductor depends on the material. That is the answer. That is the explanation. But this is just for you all to recall the activity. I am sure, students, you can remember the activity and you have written the correct explanations here. So with that, I will move on to the next question. Extra question 60. So here, of course, they have given us a circuit. You all are familiar with the circuit symbols, but there they have given what the symbols are as well. So here you can see this is the conducting wire, and here is a bulb. A filament bulb is denoted as A, and A is a bulb. Then here you can see there are batteries, dry cells. So that is labeled as letter B. Then C, you know the symbol, that is for a switch. So C is a switch. And then D, this is the symbol for a resistor. You all can remember, students, for fixed value resistors. There are different types of resistors. For fixed value resistors, there are two symbols. One is this, where you have the lines, where you have this zigzag line, that is to indicate resistor. Another one where you draw the resistor using a rectangle like that. That is also the symbol for a fixed value resistor. So here they have used the first symbol, circuit symbol for resistor. And the resistor is between points X and Y. That is how they have denoted the resistor. So you can get the information from the circuit. You can understand the information or what is indicated in the circuit. Then if we look at the question, the introduction is given. The brightness of the bulb A was observed by connecting each of the resistors 5 ohm, 10 ohm and 20 ohm between points X and Y. Now this is an activity we did in the lab, students. You all can remember. To understand the relationship between resistance and current flow, we used different fixed value resistors. We had the bulb, we connected the different resistors and we observed the current flow by observing the brightness of the bulb. And you can remember when the resistance was less. If the resistance is 5 ohms, then the brightness of the bulb was the highest. Why? Because the current flow is higher when the resistance is lower. So as you increase the resistance, when it becomes 10 ohms, the brightness of the bulb decreases a little bit. Why? Because the current flow also decreases. But when the resistance becomes 20 ohms, the bulb lights but with a very less brightness compared to the 5 ohm resistor. So from that, you all can remember we concluded when the resistance of the resistor increases, the current flow through the circuit decreases. That is why the brightness of the bulb decreases. So that was the activity we did in the lab. Now to answer the questions. When is the brightness of the bulb the highest? So when is the brightness of the bulb highest? When 5 ohm resistor is used. So that is what we need to write. When 5 ohm resistor is connected between points X and Y. That is when the brightness of the bulb is highest. You have to look at the question carefully. If it is highest, 5 ohm. If it is the lowest brightness, 20 ohm. Then, the next question. What happens to the brightness of the bulb when the resistance increases from 5 ohm to 20 ohm? What happens to the resistance? The resistance increases. So, therefore, the brightness of the bulb decreases. So, the question is, what happens to the brightness of the bulb? So, we can just simply write as decreases, or you can write it as a full sentence. We can say, brightness of the bulb brightness of the bulb decreases when the resistance increases from 5 ohm to 20 ohm. So, here the important answer is this, decreases. So, brightness of the bulb decreases, but I have given a complete answer. Brightness of the bulb decreases when the resistance increases from 5 ohm to 20 ohm. I'm sure you all can understand this activity and the related questions clearly. So, with that, students, we'll move on to the next slide. Extra question 17. Write the types of resistors used for different purposes with examples. So, write the types of resistors used for different purposes with examples. Now, what are the 3 types of resistors? You can remember. The fixed value resistor. Now, fixed value resistors, what do? We combine them either in the series combination or parallel combination. And you can remember, by combining them in the series combination, the equivalent resistance increases. So, if you want to increase the resistance of a circuit, you use resistors. But there are also, if you want to get a higher value, let's say you have 3 ohm resistors. If you want to get 9 ohms, you connect the 3 ohm resistors in a series combination. But if you want to get a 1 ohm equivalence resistance, then you connect them in a parallel manner. You can remember the way we calculate the equivalent resistance. So, there, in order to get a certain resistance and to control the current flow, we use the fixed value resistor. Then we have the variable resistors. What do we do with the variable resistors? Say in an activity, throughout the activity, if we want to change the resistance, then we can use a rheostat. You can remember when we did the activity to verify Ohm's law, we use the rheostat. So, by changing the resistance, you can get different values for potential difference and current. So, if you want to change the resistance throughout, then we use a variable resistor. Another example for variable resistor, volume controller. Now, in radios and places where sound is produced, you use the volume controller. So, there, by changing the resistor, we can use it to change the volume, control the volume of that particular device. So, that is how we use the volume control resistor. Then there is the pre-adjustment resistor. Now, pre-adjustment resistor also has a certain range that can be adjusted. So, depending on the value of resistance you need, you set it to that particular resistance and you connect it to the circuit. So, instances where you need to have a certain resistance for a circuit, you can use a pre-adjustment resistor as well. So, those are the variable resistors. Then we have the light dependent resistor. What happens with the light dependent resistor? When the light intensity is low or in the darkness, the resistance is high. So when the light intensity is less, when light falls on it, the resistance decreases. So instances where the current has to flow when the light intensity is high, we can use that particular resistor. So like that, we can use different types of resistors. So to answer this question, write the types of resistors used for different purposes with examples. So here, first one, fixed value resistors. So when we say fixed value resistors, they are used to obtain a certain amount of resistance in the circuit. So here we can say to obtain a certain amount of resistance or to provide a certain amount of resistance in the circuit. So there has to be a certain resistance in the circuit. So this can be combined how? They can be connected in series combination or parallel combination depending on the resistance required. So you don't have to go into detail about what happens to the equivalence resistance when we connect them in a series combination and parallel combination, but you all have to have that idea, students. So fixed value resistors, they are used to obtain a certain amount of resistance in the circuit. So why? To control the current flow. So this is done to control the current flow through the circuit. Then we have the second type. We can say variable resistors. Now under variable resistor, the first one, rheostat. Rheostat is used in laboratory activities to change the resistance during the activity. For example, verify the ohms So during this activity, we use the rheostat. Then we have the second type, we have the volume control resistor. So using the rheostat also, we change the resistance during the activity. By doing that, we change the current flow. But when it comes to Ohm's law, we get different readings for potential difference and current flow as well. Because you can remember, students, in that activity, when we measure the potential difference and current flow, that was across the nichrome coil. Why? Because we wanted to calculate the value of the resistance of the nichrome coil. To do that, we needed 5 sets of readings. So to get that 5 sets of readings, we use the rheostat. We change the resistance of the full circuit. Then the current flow and potential difference change, and from that we were able to find the resistance of the nichrome coil. So that is how we use the rheostat. In a similar manner, we can use a volume control resistor in devices. There again, when you rotate the volume controller, you have seen these volume controllers in radios or places where you need to change the volume. So there you have seen, by rotating it, you change the resistance. By doing that, you can control the volume. So volume control resistors, by turning the control knob, the resistance is changed. And then the volume can be changed. Now, even though we don't use volume in an activity, now we'll be discussing these types of activities later in your next grade as well, where there is no sound produced. But still, by turning the knob, you can change the resistance of the circuit. So this part, changing the volume, is kind of optional. If it is in a device, you will be changing the volume. But if it is during an activity, by turning the knob, you will be changing the resistance. I'm sure you all can understand that. Then we have the next one. Again under variable resistors, pre-adjustment resistors. So what is the advantage of using pre-adjustment resistor? Now, when we discuss fixed value resistors, you can remember, students, we use more than one resistors, combine either in a series combination or parallel combination to get a different value for the equivalent resistance. So there, by using the resistors you have, you can only get a certain equivalent resistance. In a similar manner, if you use a pre-adjustment resistor, you can use just one resistor, one pre-adjustment resistor to get a range of resistances. But the thing is, you have to adjust it. Say if the range is between 100 to 500 ohms, then you can have it at 100 ohms, 115 ohms, 124 ohms, 148 ohms. Like that, you can keep on changing it. Even 200, 250, like that, you can change the resistance within that range. But the thing is, you have to remove it from the circuit, you have to adjust the resistance, you set it to a certain value, and then you connect it to the circuit. That's how we use the pre-adjustment resistor. So the use of this is, using one resistor, you can set it to different values. So here, one resistor is used to obtain different resistance values. So that is the pre-adjustment resistor. So we have discussed two types, fixed value resistor, variable resistor. What is the third type? The light dependent resistor or the LDR. Then the next one, light dependent resistor or what we call as LDR. So here of course resistance is high when the intensity of light falling on the resistor is low. When the intensity of light falling on the resistor is high, the resistance is low. Or in other words, you can say when the intensity of light falling on the resistor increases, the resistance of the resistor decreases. Either way is fine. So here, how can we use it? If we want a circuit to function, if we want the current to flow through a circuit when there is light, then we can use this type of resistors. When there is light falling on the resistor, resistance is less, then there will be more current flowing. And when there is less light intensity, the resistance will be high and the current flowing through the circuit will be less. So if you want to control the current flow through a circuit based on the intensity of light, then we can use this resistor. So here we can say the LDR is used to control the current flow through a circuit depending on the intensity of light. So the LDR is used to control the current flow through a circuit depending on the intensity of the light. So these are the different types of resistors and their functions. We will quickly go back and go through the answers. So the question was to write the types of resistors for different purposes with examples. The first one, fixed value resistors. Fixed value resistors. They are used to obtain a certain amount of resistance in the circuit. They can be connected in series combination or parallel combination depending on the resistance required. That is why we calculate the equivalent resistance. So this is done to control the current flow through the circuit. All the resistors are used to control the current flow through the circuit. Then we have the variable resistor. So we have variable resistors. Under that, first one we have the rheostat. Rheostat is used in laboratory activities to change the resistance during the activity. For example, when we verify the Ohm's law. Then we have the volume control resistor. So here the resistor, the knob is similar to a volume control. By rotating it, you can change the resistance. By turning the control knob, the resistance is changed. And here, if it is used in a radio, then of course the volume can be changed. Otherwise, the resistance of the circuit will be changed. Then we have the next type, pre-adjustment resistor. So pre-adjustment resistor, one resistor is used to obtain different resistance values. So there are, of course, you change the resistance first and then you connect it to the circuit. That is the pre-adjustment resistor. Then we have the next one, the light dependent resistor or LDR. Resistance is high when the intensity of light falling on the resistor is low. When the intensity of light falling on the resistor is high, the resistance is low. So, what do? Therefore, the LDR is used to control the current flow through a circuit depending on the intensity of the light. So, that is how we use the LDR. So, I am sure students, you all also know the functions or uses of these different resistors and you have written the answers in a similar manner. So, with that, I am going to move on to the next question. Now, extra question 18. Draw the circuit symbols used for fixed value resistors and variable resistors. So, you can remember students, there are three main types of resistors. We already discussed that. Fixed value resistor, variable resistor and light dependent resistors. So, for those resistors, we have different circuit symbols and even for each resistor, the variable as well as the fixed value resistors, there are two circuit symbols. If we look at the symbols, now here you can either have this zigzag line or you can have this rectangle to show the fixed value resistors. Fixed value resistors. Fixed value resistors. Then we have a similar circuit symbol. Again both, but when you have this zigzag line, across that, if we have an arrow like that. Now, this is a fixed value resistor. When you have an arrow across it, it becomes a variable resistor. Same goes for this one. When you have the circuit symbol of a fixed value resistor, across that you have an arrow. So that shows the variable resistor. So both these, the first two symbols can be used for fixed value resistors and these two symbols are used for variable resistors. So draw the circuit symbols used for fixed value resistors and variable resistors. Then you can remember, it's not asked in the question, but you can remember students if it is the light dependent resistor. We put a circle around this and show arrows to indicate the light falling on it. So that is the symbol for light dependent resistor. I'm sure you can recall that symbol as well. So these are the circuit symbols. So with that, I'll move on to the next question. Extra question 19. A resistor with 4 color bands is shown in the diagram. So you're familiar with that, students. Normally fixed value resistors, they have 4 color bands, and that is the color code system that is used to calculate or determine their resistance. So here in the diagram also, here you can see a fixed value resistor with the 2 terminals and the 3 bands. When you look at them in such a way that the 3 bands that are closely arranged are on the left hand side. So you start reading the colors from this band. Then you can see after the 3 bands, there's the 4th band that is slightly away from the first 3 bands. That's how we look at the resistor. 3 bands are close to each other. There's another band that is separate. So you have the 3 bands that are closer to each other onto your left hand side. Then you start reading the colors from the left hand side like as labeled here, A, B, C, D. Now we'll look at the question. The resistor is placed in such a way that the 3 closely spaced bands are placed to the left. That is what I explained now. Write what is indicated by the bands A, B, C and D. You all can remember that, students. What is band A? The tens place. Then band B, ones place. Then band C is the index to the power of 10. And band D is the tolerance value. So those are the different bands. Band A, tens place. Band B, ones place. Then we have band C, index to the power of 10, and band D, tolerance value. So those are the 4 bands. Tens place, ones place, index to the power of 10 and tolerance value. I'm sure you all were able to identify the 4 bands. With that, I'll move on to the next question. So extra question 20. Here of course students, you all can see they have given you a fixed value resistor with the 4 color bands, and you can see brown, black, orange and the red color marked there. So from left, if you read the first 3, tens place, ones place, index of to the power of 10, and then the tolerance interval is red. And normally in your exam paper, they will give you the values corresponding to the color bands. But now that you have the textbook with you all have the table in the textbook. You can look at the table and get the values. So you will remember, students, the values for brown is 1. Then we have black 0. Then we have orange, the value is 3. And red is 2% tolerance interval. So those are the values that you can refer, get or obtain from your textbook, the table given there. Then if we are to calculate the value, the first question, or before that we have the information, a resistor marked with brown, black, orange and red colored bands is provided to you. And the first question is, find the value of the resistor. So how do you find the value of the resistor? Always for the first color, you write the value 1. Then second color also, you write the value directly. Black is 0. Then the third color, orange, 3. That is the index to the power of 10. So when you say index to the power of 10, 10 to the power of 3, so you need to add 3 zeros. So after 10, you add 3 zeros. That is the value of the resistor, ohms. 10,000 ohms is the value of the resistor. So 10,000 ohms is equal to 10 kilo ohms. We will leave it as 10,000 ohms, but you have to know 10,000 ohms equals 10 kilo ohms. You should be familiar with this value as well. You can convert the resistance to kilo ohms as well. So 10,000 ohms is 10 kilo ohms. That is how you find the value. The first two colors you write the value directly. Brown has a value of number is 1, black 0, so 1, 0. But the third one, orange, the value is 3. Accordingly, we write 3 zeros. So 10,000 ohms. Then, what is its tolerance? So here, if you are to calculate tolerance is 2% because the color is red, 2% tolerance. If we are to calculate tolerance equals for 100 it is 2, therefore for 10,000 that is equal to 200 ohms. You can simplify it easily. 200 ohms. That is the tolerance. That also is in ohms. Then the third one. Find the range of values that the resistor could have. How do you find the range of values? You add and subtract the tolerance from the resistance. 10,000 ohms plus or minus 200 ohms. So that is going to be from 10,000 minus 200 ohms to 10,000 plus 200 ohms. So that will be from, so when you subtract 200 from 10,000, that is going to be 9,800 ohms to 10,200 ohms. That is going to be the value. 10,000 minus 2,000, 9,800 ohms. 10,000 plus 200, 10,200 ohms. So there is a tolerance range or range of values that the resistor could have. It could have values from 9,800 ohms to 10,200 ohms. So that is how we use the color code system to find the resistance of a fixed value resistor. You look at the color band starting from left and you find the value of the resistor. Again, brown color 1. So you write the value 1. Black 0, you write the value 0. Orange 3, but since it's the third line, you put 3 zeros. So 10,000 ohms. Then red, for tolerance, it's 2%. There, you calculate the 2%. If we say 2%, if the resistance was 100 ohms, the tolerance will be 2 ohms. But here the resistance is 10,000 ohms. Therefore, you get the value of tolerance as 200 ohms. Then to find the range of values that the resistor could have, you add and subtract the tolerance value from the resistance value. Resistance minus tolerance, 10,000 minus 200 to resistance plus tolerance, that is 10,000 plus 200. So you will get the range as 9,800 ohms to 10,200 ohms. So that is how you calculate values related to fixed value resistors based on the color code system. I am sure you all can understand that and you would have done the calculations also correctly by yourself. And with that, students, I am going to end this chapter, and in the next chapter also I will discuss some more extra questions with you.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.